Hi everybody. The purpose of this video is to show you how you can do some of your background processing for Experiment 3 in Microsoft Excel. As I mentioned before, Excel is a tool that you are going to want to become familiar with. It is a very powerful tool whenever you have to do some kind of simple data processing or other type of numerical thing or numerical processing. It is powerful. Sometimes the learning curve is a little rough, but with a little persistence, there's lots of things you can do with this. Now, if you recall, we collected enough data so that we can actually compute our velocity, compute our acceleration down the ramp using this particular formula. We collected time for a variety of distances, and recall our equation that we're going to be playing with is that the distance traveled is going to be equal to 1/2 times our acceleration times time squared. And we've collected time. We can compute an average, and we can actually compute time squared. We're actually going to have that down here somewhere, right down here. Okay. Now, given that we are going to have a value for time squared, we can actually do regression, noting that here that d is going to be y, 1/2 a is going to be our slope, and t squared is going to be our x value. That means we can do linear regression, and once we have done that, we know that our acceleration is going to be equal to 2 times the slope that we came up with in our regression. And then we can also estimate g, because g is going to be equal to whatever we got for acceleration divided by sine theta, and this is how we could compute sine theta. Okay, so we did our experiment. We collected all of this fun data. Hang on a second, I need to delete this. And the question is, how can we use Excel to make this work? Well, notice what I did was I put all this data into a spread into my table. Basically, I typed it in, and I can and since I've done that, I can do some copying and pasting. The first thing I want to do is come over to Excel and essentially prep my spreadsheet. And I'm going to do this as follows. I'm going to have D, all right? I'm going to have my 5 values of T: T1, T2, T3, T4, T5, and for D, I'm going to have 0.25, 0.5, 0.75, and then 1.00, just simply 1. Okay, now that I've done that, I can go ahead and I can copy my data, or you can just type it in. It's not going to take too long. And then paste it in my spreadsheet. The way I'm going to do that is I'm going to come to this cell right here. I'm going to right-click. It has to be a special paste, and I'm going to use this because I don't want any of that formatting stuff. And there we go. It's in there. And also what I want to do is I'm going to highlight this and hit bold, and I'm going to highlight this. No, not that. This, and hit bold. Hopefully that will keep me from including this in my averages and in my computations. Okay, so now if we come down to this table, what do I want? Well, I want my average. I'm just going to call that T average. Okay. I want my standard deviation. I want my absolute error, that's alpha, just call it that, and I want t squared. I'm just going to call that t comma squared. Okay, boom. Now, if you don't know what formula to use, what you can always do is just come down, get into the internet on your favorite web browser, and you can type in something like average Excel, and it'll most likely be the first thing that actually comes up. We're going to use the average function. So we're going to come over here, and whenever we're doing a formula, we always start with equals. That's how Excel knows that we're actually going to be doing a computation. And then we're going to type in AVER, and there it is. There's average. Once you see that, and it's you can either highlight it using your cursors, or but once it's highlighted, you can hit Tab. It will complete the formula. And now what we want to do is highlight the times. These are the times. Okay. Now you should put an parenthesis at the end, but you don't have to, because Excel is actually smarter than it used to be, and we'll put that down there. For standard deviation, we can do the exact same thing. If you're not sure, you can type in standard deviation in Excel, and it will come up with some ideas of what formulas you can use. In this particular case, I kind of already know what it is. That's going to be equal STD, and there we are. We have population standard deviation. We have sample standard deviation. We probably should use sample, but I'm not going to. I'm going to use population. Okay, once again, I can hit tab. Okay, it completes it. I can highlight these values again. Close my parenthesis. There's my standard deviation. Now, this is absolute error. Absolute error, once again called alpha, is defined as your standard deviation, technically your sample standard deviation, but I'm not going to make a stink over that, divided by the square root of the number of samples you have, which in our case is going to be the square root of 5. Okay, the formula for square root in Excel is SQRT, and that's what we're going to be doing. So over here in Excel, I can hit equals, and I want that number right there. That's my standard deviation. I can do it just by highlighting that, divided by SQRT, parenthesis 5, close, and there we go. Okay, and then finally, what we can do is we can square our time. That's going to be equal to, here's our average, well, right there. Okay, shift 6 gives you the caret. That's for to the power of 2. There it is. Okay, now once I've done that, I can copy all of this and then paste either the entire section like this, or at least the header, that the first column of the next 3 rows, and hit paste, and it does all the computation for me. Okay, and then we're done. It does all the computation for us. And now, if you want, you can transfer this information into here. You can actually do that pen and paper, or you can do it automatically. The problem with doing it automatically is you need to pay close attention to your significant figures, because you need to have 3 for all of this stuff. If you wanted to do that, it's a little tricky, but I'm going to show you how to do it anyways. You highlight all of this. Now notice what here, I'm going to hit copy. Or you can do Control C for you Windows people. All right. And now the first thing you have to do is realize what I'm doing here is I'm copying values, or no, I'm copying formulas. I do not want the formulas. I want the values. So if I did a regular paste, it would paste the formulas, and those formulas would not track back to these original values, and everything's going to be messed up. I can actually go ahead and show you. See. Makes no sense whatsoever. So instead, what you have to do is you have to basically do a paste special, and over here that's values. Click on that, and then only the numbers are copied over. Okay, see, over here I have a formula. Here I just have a number. Once I've done that, now notice here everything in this column belongs in this particular row. Or in this particular row. I didn't include the 2.5 over there. Okay. Now I can't copy them directly, but what I can do is I can copy these. Okay. I can come over to another Excel and I can click Paste Options, Transpose. That turns these columns into this row, and of course then these rows into that column. Then if I wanted to, I could copy all of this, and keep in mind that is not distance, that is time. That's that value right here. I can come over here, I can right click, I can hit paste. You want to paste overwrite cells, and there you go. Now what you'll also have noticed is you lost your lines. What you can do to fix that is highlight all of this, go to Table Design, Borders, click all borders, and they'll be back. Now the only thing that you're going to have to do is by hand make sure you have the correct number of decimal. Make sure you have the correct number of significant figures. There should be 3. You would need to do that by hand. So you can either do that automatically or automatically, like we just did, or you can just handwrite them in there. It's entirely up to you. Okay, now the next thing that we need to do is a linear regression. Once again, if you're not too sure how to do that, you can always type in linear regression Excel. There it is. Okay, it will give you some ideas. This basically is doing it, we're going to do it this way anyways, but what I'm looking for is essentially an approach that tells me how to use the command linest right there. This one also, if you go on down, you will actually find that. Fortunately, I already know how that works, so let me go ahead and knock that out. So I'm going to make this bigger now, and I'm going to start down here. Okay, now for linear regression, I can type in equals LINEST parenthesis. Okay, now my known y's, those are the d values right here. Okay, comma, my known x's, that's t squared right here. Okay, comma, and that's really all I have to do. I can do the constant stats things, but it's not really necessary because they're optional and they'll just default to the ones that you see right there. So I'm going to go ahead and close, and there you go. That is my slope. That is my y-intercept. Okay, so my slope, I'm going to call that m, is equal to that value right there. That's my slope. Okay, that's the m right here. Okay, I want the acceleration. Remember, the acceleration is 2 times m. Okay, so that's going to be, my acceleration is going to be equal to, well, is going to be equal to 2 times that number right there. Just highlight and hit enter. So that's my acceleration. Now I need to figure out my what my velocity is. Now before I can figure out what my velocity is, I need to know what sine theta is. Of course, you can do that on your calculator, or you can go ahead and do it here. So what I'm going to do is here I'm going to have h, I'm going to have w, and I have these in centimeters. You can do it in meters. You just can't have h be centimeters and w be meters. That would be kind of a mess. So here my average h is 8.3. My average w was 118.7. Okay, so my sine theta, and it might be good to do this so you can keep track of what's what. That is going to be basically using this formula. And I'm going to do it all in one line, but I'll be nice and slow about it. That's going to be h, okay, divided by, just hit the divided by key, square root sqrt, parenthesis, h squared, there's h, shift 6 for the hat, squared, plus w squared, that is that value right there, shift 6, w, 2, sorry, close the parenthesis, that is sine of theta. Okay, now remember, g is just nothing more than a times sine theta. It's right there. Okay, cool. So we are going to, we'll put g here, and then g is going to be equal to that number divided by sine of theta. And there, I actually got a g of 10.09. If I was going to put that in here, it would be 10.1, which is reasonable. I mean, if you think about it, we are on a track. We kind of did a really rough estimation of what theta was based upon, our meter sticks and what we considered vertical and whatnot. I mean, we have a track. We're on a track. There's a little friction on that track, so that the wheels could be slipping. There could be a little resistance in the rotation. So it would make sense that this would be a bit smaller than our actual value for g. The other thing that we need to do here is we need to compute our percent error. Okay. Well, the way we can do that, that's just going to be what? Percent error, percent. Remember, the percent error is, hang on a second. There we go. Is going to be equal to the absolute value of your estimate minus the actual value for G, 9.80, divided by actual value for G, which is 9.8, times 100. Okay, to do that here, that is going to be, okay, now since I know this is larger than 9.8, I'm going to start with that one. That's going to be equals to, parenthesis, that value minus 9.8 close divided by 9.8 times 100. That is my percentage, 3% or 3.05%. So that's our percent error. Now, the other thing here is the correlation is R. Now, I don't believe I talked about R in here. Was that a mistake? Did I? Which would have been a mistake on my particular part. Yeah, calculate the correlation coefficient. Okay, so how do you do that? Let's go ahead and find out. What we can do is bring up our window here, type in correlation coefficient, there it is, correlation coefficient Excel, and look what it tells you. It tells you want to use Corel, just like this. Enter the formula Corel with our two ranges. Now, once again, we are working with distance and time squared. Okay, and what the correlation coefficient is a measure of how linear the relationship is between those two data sets. Okay, if the correlation is very close to 1, then it is very linear with a positive slope. If the correlation is -1, it is very linear with a negative slope. So that's what we're going to try to figure out here. So correlation, I'm just going to type in CORR, or I just type in R. That's going to be equal to X. No, Corel. That's what we found. There it is. Okay. Then it doesn't matter the order here. We just want to do D for one. Okay. T squared for the other. If you did it in the other order, you're going to get the exact same value anyways. Close your parenthesis. That is my correlation coefficient, 0.989735. From that case, it would be 0.990 if we stick with three significant figures. Okay, so that's how you do that. Now, I did tell a couple of students that you do not have to put that in there. That was a moment of weakness. If you don't, you're not going to break my heart. I'm not going to crucify you for it. I'm not going to make points against you for not doing that. But it's not that hard. So go ahead and do it. All right, so we have all that. So that takes care of filling out the table. We can actually put all that information here. I'm not going to, but since it's there, since it's here, you can. The only other thing that we actually have to do I don't explicitly state it here, do I? But notice here that I have a spot here for displacement versus time. So chances and displacement versus time squared. So yeah, I'm kind of expecting you to do that. Now I did not discuss that in class, but hey, I'm going to do it now. Okay, so here it goes. For this particular graph, how can we do that? Well, the easiest thing, in my opinion, is first to take take these values right here, all right, and copy them and just paste them to a column, like right here. Okay. And then take these values right here, copy them. Now remember, these are formulas. Come to the column before that and paste them as values. Okay. Now, once you've done that, you can then highlight both of these values. Okay. And then come over to insert, and we want to insert a scatter plot with straight lines. Basically, we want to insert that. Okay, so there's our graph. Now we also want to do a little work with this. We just don't want to just leave it like this. We were going to write, so we can in the chart title type in displacement versus time. Okay. Then we can come over to add chart element, axis titles, primary horizontal. That will be time in seconds. So you want to do this, don't be proud of your work. time in seconds. Make sure it's spelled correctly. Come back in here again. Axis titles, primary vertical. That is going to be displacement in meters. So you can highlight it, double click it, click some more. Displacement meters, that's probably good enough. Another thing that you could do is mess with the axis values. Now, how could you do that? Well, what you could do is go into form. Is that it? Oh, click your axis. Okay. Don't want to do that. Don't want to do that. Yeah, and bring this down. Okay, so basically, let me show you that one more time. Click your axis, click that button right there, and what I want to do is, at least for the x-axis, I don't want this starting at 0 and going up. I want to get rid of all this stuff. So I'm going to bring this up to about, I don't know, 0.5. And then the max, I guess I'll leave at 1.8. My major units, I guess I might want to bring that to 0.1 to make it look better. And that's probably all I want to do. So that is, my opinion, is a good graph. Now, why does it look like this? Well, the reason why it looks like this is because this is a very, very small part of the parabola that you have right here. You can almost see the parabola beginning to make its move up. So that's why it looks the way it does. It's really 4 very small samples of an actual parabola. But nonetheless, we need to get this into what we need to get this into our report. Cool. Copy. Come over here. Paste. You can paste it as an wait, let's see if I make sure I copied it. Copy. Okay, come over here. Paste. Okay, and we can paste we can paste it like that. Keep source formatting. If you want, you can paste it as a picture. Any of these will work. So there you go. It's in. Now, what about displacement versus time squared? Well, we can do a similar thing. Now that this is pasted, we can get this out of the way. We can try to get it out of the way. Will you please get out of the way? Being very difficult. There, we can delete it. Okay. Well, now what we can do, since we're dealing with time squared, I want to copy this, okay, and I want to paste it right here. Once again, I got to paste the values. Okay, there we go. And I can do the exact same thing. I can highlight these. I can do insert this chart right here, this scatter plots, that right there, and here we go. Here's my graph. Now for this one, well, we're going to do the similar stuff. First thing, we're going to change our title. This is going to be displacement versus time, and then well, we can do time squared. Just leave it like that. There's a way to put the 2 in the as a superscript, but I'm not going to deal with that right now. But maybe we should also, since this is a title, we should probably have this in title case. All right, there we go. Once again, we want to add our axis titles. So add chart element, axis titles, primary horizontal. That is going to be time squared in seconds squared. Well, if I wanted to do superscript, that would be Control Shift plus squared, Control Shift plus to bring it down. So that's how you would do that. Then add the Y element. All right, so that is going to be primary vertical. That is going to be, once again, displacement in meters. There you go. I didn't realize that you could just type it in just like that, but live and learn, right? Okay, and now what I need to do, there's one more thing that we can do, particularly for this particular graph, since we know this should be linear. I can come into here, I can click trend line, and notice we have linear trend line. Okay, I can click on that. There's my trend line. Once again, I can click on here again, and I probably should have done this the first time, and I can go down to more trend line options. Brings this thing up to the side, and I can, once again, it is I want it, well, that's, I don't want that. I want trend line options there. Okay, I want linear. Cool, it's linear. And I can also come down here and click display equation on chart. There's my equation. Ironically, or as we would hope, it has the exact same value that we have for slope right there. Okay, which also is the other way that you could do linear interpolation. But if you do it like this, then you can't, well, you could, but you would have to type that number into here, and then you could do the exact same stuff. Okay, so now this is pretty much the way I want this. So now I can copy this. I can come over here. I can click paste. And actually, any of those paste alternatives will work. Of course, now I might want to clean this up a little bit. So delete all of this, because it might be good to have all this on one page. And there you go. You have your displacement versus time squared curve, your displacement versus time. You have everything that you need to fill this out. As a matter of fact, if you wanted to, and I assume you're not going to get, you're not going to get on my way again, are you? Of course not. There's a way to do that, but it is eluding me right now. But I can still delete it. If I wanted to, I can copy all of this. Use the overwrite cells. Copy this. Paste it here. Get rid of that. Copy this, paste it here, highlight all this crud, come to table design, borders, all borders, and I'm back to where I was. And of course, there's also some things you can do to make this neater if you choose to. But that is pretty much everything I wanted to show you. Damn, I'm sorry it's taking a half hour. I thought I would do it a lot faster than that. But nonetheless, that is pretty much how you can use this to do all of your data processing. Okay, and I'm thinking that it should not be that bad. It might be a little rough the first couple of times, but this is a great tool that you can use to actually knock some of this stuff out, and also put this stuff into my and also the transfer what you need to transfer into your report. As always, if you have any questions, please feel free to contact me, email or text, and I will get back to you as soon as possible. And hope you guys have a great weekend, and I will see you on Monday. This is Bob Boyle signing off.